Hour. Good morning, everybody. I'm Jeff Moats, and welcome to this presentation, GIS Day 2021 for Elevate Your Drone Imagery in ArcGIS System. Joining us today is Mr. Tom Sweet from Esri. Um, if during the presentation you have any questions of Tom's presentation, please enter them into the chat window. At the end of the presentation, I will relay those to him and we'll be able to address them accordingly. Tom Sweet comes to us with over 30 years of industry and has worn many hats, but it's always focused on pioneering the use of imagery to support the business of governance in innovative ways. Before joining Esri in 2012, he served as chief of the Information Technology Group of an 11 county council of governments. Ladies and gentlemen, please welcome Mr. Tom Sweet. Tom, it's all yours.
Good morning, and thank you. And thank you, everybody, for sharing your time with me today. I'm going to try to do two 90-minute presentations in 45 minutes. So we'll go quick, and hopefully we'll have some time available at the end for questions and answers. Before I get started, I wanted to give you a brief introduction to how we see imagery. I'm on the imagery and remote sensing team at Esri. There's about 20 of us. And my specific expertise is supporting local government, state government, and public safety. And I tend to lean towards how imagery can be exploited or remotely sensed content can be exploited in the support of the business of governance, if you will. I have others that we can call upon to do deeper dives into other subject matters, including how to extract that precious knowledge from remotely sensed content and create knowledge, if you will, or wisdom to make informed decisions. So for us, it all kinds of starts with content. There we're collecting whatever remotely sensed content is applicable to our area of interest. In this case today, we'll be talking about drones. Next, after you've captured reality, you start to do an assessment of, again, reducing the pile of content into some organized fashion so that you can start to do some planning or some modeling, those types of activities. Then once you're further refining the material, you can start to make some observations relevant to your interest and start to really hone down that content to knowledge to wisdom kind of thing. And from there, you start to take your the patterns that you've seen and you exploit them, whether it's whether your area of interest is national, local, or state, whether it's environmental, whether it's parcel, whether it's engineering grade kinds of activities. Those are all things that to us fall into the ArcGIS imagery system of systems. So part of that involves that we are constantly increasing the number of sensors that we can deal with, the number of formats that we can deal with, and overall, all of the different capabilities that are required to exploit remotely sensed content. Imagery is coming at us in greater quantities these days, at a higher velocity, as well as in increasing numbers of sources. So that requires that we continue to expand and evolve the platform. This is obviously it's important as we start to drill into drones as our, in this case, sensors of choice. So imagery, the important takeaway from that slide is that it's expandable, it's contractible. The ArcGIS imagery system of systems is fairly complex. It can expand to fit a large enterprise or condense down to fit into a small element of local government or even an agency within it. But basically, it all kind of comes together with doing capturing reality, making your observations, and then possibly doing some detailed inspection work, and then evolving it into as I said before, knowledge. And for most people, ArcGIS Pro is probably all you'll need. For others who want to do a more in-depth types of analysis, some of the extensions may be plausible, like specifically ArcGIS Image Analyst extension for Pro, particularly if you want to get into full motion video work with your drones. So as we start looking at the drones, it's important, I think, to understand why they're important. Typically, there are many sources of content, some satellites, some fixed wing aerials, some mounted on vehicles. Drones tend to fill a gap in the middle that allows elements of government or public safety, or the private sector in terms of the AEC firms, to fill in what they need to know in both an area and in terms of currency. And by currency, I mean keeping that up to date, while your traditional collection methodologies may be, every year, every 6 months, every 2 years. With drones, they're cheap, they're easy to throw into the air, they're easy to go collect what you need to collect, and then bring it back and fill in that gap. So with drones, it's more than just simply flying the drone. In fact, what I find most challenging sometimes is getting the operators to not fly the drone. Let the robot be a robot. That way, you're going to be able to use the flight planning apps to assure that the content that you're collecting is done in a way that's consistent with the best standards of photogrammetry. So there's all kinds of things to consider. The type of drones, what kind of sensors on the drones, how you're doing the planning, is your airspace restricted, and more. And we'll touch upon some of that today. But there's a couple of points that I would like to really highlight. One is the products. This is more or less a summary slide. Sorry for all the words, but it kind of shows the 3 different types of orthomosaics that you can produce. And I think one of the, not only does it do the traditional nadir type downward looking orthomosaic, but you can also get into dynamic orthomosaics, which is in the screen on the right. As you pan around, and we'll see this a little bit in the demonstration, as you pan around, you can actually see the sides of the buildings, the north side, east side, west side, whatever is available based on the orientation of your sensor. The other thing that I think is important to always keep in mind is that it is important that if you're going to produce authoritative content, in other words, content that can have some degree of known accuracy, so you know what you're working with, it is important to make sure that you adhere to the best practices of photogrammetry, and that in this case includes, what we're talking about is the overlap required to maintain and give you the best accuracy possible. So in that sense, it's important to fill out your, make your flight plan, let the system apply the best practices, define that flight plan, connect to your drone, and then go fly the drone. So when we look at drone, the kinds of products, we can more or less break it down into 3 areas. One is 2D, which most commercial drones can do. Then you start to get into the 3D, where you can do elevation products. You can work with point clouds. You can work with 3D meshes. And then finally into oblique imagery, where you can start to do, as I said before, A side, B side types of examination of the object in question. You can further divide these products into some typical uses, and these are the use cases for drones are far and many and very different. So Today, we're going to try to group them into some general categories. One is the obviously the base map, where you're doing some general orthodynamics, or you might be doing some contours for a fairly large area relative to what drones can do. And then you can drill down a little bit further and get into site modeling, where you're now looking at a perhaps smaller scale at a smaller area of interest, and then actually at the end get into some inspection and monitoring activities, where you want to look at a tower, or you want to look at a dam face, a specific item, and you want to look at it in a way that you can do some basic calculations, you can do some measuring, and you can start to annotate for other teams that you may want to send out into the field. So, at the heart of all this is in the best practices standpoint, it is important that you know to some degree what your accuracy the accomplished accuracy that you've been able to derive based on your flight plan. And one of the advantages, if you're using a system that generates an accuracy report from the triangulation solution, it helps you document whether or not the accuracy that you achieved is the accuracy that is required for that particular use. So when you start looking at using drones and the ArcGIS system of systems, there's really two products. One is Drone to Map. It's been around for a long time and has proven itself. And the other one is SiteScan for ArcGIS. To me, at a high level, the difference basically is the desktop version, where you're in a disconnected state, and you don't want to use the cloud. You don't want to use elastic processing. Is Drone to Map is your solution. If you are in an environment or a deployment pattern where you can use the cloud, where you do want to take advantage of what the cloud offers in terms of elastic processing, and doing an end-to-end solution, then from tasking all the way to the dissemination of the products that are created. Those are essentially the differences between the two solutions. And we'll probably drill in more into SiteScan today, but I wanted to show both so that you could make a comparison and informed decision. So as an overview, doing map production in Drone to Map is basically you're going to use the Drone to Map to go out and acquire your data. You're going to then process the data on local infrastructure, and then either that output could be done in Drone to Map, or it could be done in Pro. Once you get back to the office, and you can create basically the same products. It's important to understand that throughout the life of all of this, we are continuing to add new capabilities all the time, and we do that by collecting user input. Some of it is, boy, this doesn't work very well, how about fixing this? Where others is, wouldn't it be nice to have? And so both of those are important to us, and it's the principal way that we continue to evolve or grow the product. In this point, I think I would, the thing that I would take away again are the ability to generate the dynamic orthomosaics, and then you can share it out through the ArcGIS system of systems, depending on what components you've already deployed, whether it's ArcGIS Online or the enterprise. Most of this, as I said earlier, is built on the Pro platform. So if you have Pro, you're that much further ahead, and you can take advantage of the processing components that are in Pro. When you start looking at taking that workflow and modifying it to deal with, let's say, a simplified overview of what SiteScan brings, you'll see a lot of similarities. It brings the additional capability of the flight planning tool, as well as the management interface, so that you can control things like projects, like users, like access, in those types of things. It still can be capable of generating out through the same sources through ArcGIS Online or the enterprise. One of the distinct advantages is that you now have access to elastic processing, and by that I mean in the cloud, as you throw more images at the processing engines, they spin up more CPUs and GPUs to deal with the increased number of images as you throw more images at it. And that's scalable. It spins up and it spins down as you need it. There's no other impacts. Depending on your deployment pattern, you could also be looking at unlimited storage in the cloud. Or you could be looking at, if you deploy it differently, unlimited licenses based on a set number of images. And again, what starts to come into play with the site scan process is the increased ability to share externally. In this case, I'm talking about with Autodesk and BIM 360. That is there now today. And as I was talking with Dev to kind of get a peek at what's coming, the DXF integration that should make it easier to get into things like Bentley should come out in the next release. So just wanted to highlight before we moved off this to a little bit deeper dive. The important thing to understand in these workflows is that you have the ability to work with all of the rest of the platform. You know, whether it's Survey 123 or any other piece that you've deployed, it all becomes something that's doable. And then now with the advent, again, as I mentioned earlier, with ArcGIS Analysts extension, you can now take the metadata that SiteScan Flight captures and has set up in the flight planning process and use it to feed directly into the video multiplexer that is found inside ArcGIS Pro and the full motion tool, the video tools that are found in the ArcGIS Analyst extension. So just to be clear, you know, what we're talking about here, there are two different applications that can both work independently. In some instances, I've worked with some organizations that deploy both, depending on their deployment environment. But in all, it's an end. You know, with specifically looking at SiteScan, it's an end-to-end solution that begins with you know, tasking and collecting and ends with dissemination. Or the process looks kind of like that in terms of end-to-end. You basically start with the tasking, then you move into collecting, then you're processing your content based on your area of interest, then you're exploiting it to make it more useful to the decision makers, and then disseminating that information out to all of the people who are authorized to work with it, to see it, and in some cases that includes the general public. So looking at SiteScan, again at a high level, it basically has the flight planning component. You can use the fleet management processes. It brings to the table more enhanced image processing and image analysis, and a richer set of tools in sharing the content. When we look at you know, generally using unmanned aerial systems, they're providing tremendous new capabilities to, all types of organizations, state governments, local governments, public safety teams, utilities, AEs, construction firms. Pretty much, your imagination becomes your limit, and to some degree, how much you want to invest in the drone and the sensor. In this particular instance, one of our users took a drone, commercially available off the shelf, and captured this airport. It took him 3 days to collect 4,800 images, and it took about 72 hours to process. The point here is, and he made a highly accurate 3D mesh, because he was using pretty good ground control. And the point is, all of this is that, one of the things that drones excel at are mapping microgeographies. So it can start in a number of ways. There are, let's say, 3 components that we've talked about, right? The flight planning app, we've talked about some drone to map work, and we've talked about some site scan work. And I thought it might be useful to actually, rather than listen to me rather on, is to look at a couple of short videos that show how these products are actually used. So in the first one we'll deal with is the flight planning app. Both drone to map and site scan share the same flight planning app. Drone to map uses a free site scan Flight LE for limited edition, where the site scan product uses the more full-blown capable product. But essentially, they're both going to allow you to plan flights the same way. So let's take I had one of our pilots record this.
This demo will show how to use the site scan flight planning application. Opening the app on your iOS device, you can connect to a previously flown project or start a new one. Here I'm connecting to one that was flown over a bridge. This list of drones are the supported drones that can be used with this flight planning application. I'll go into a previously flown flight, such as this crosshatch pattern for the bridge dataset. Since this flight was already flown, you could see the flight plan in its entirety. I'm going to make a few edits to this to show you how easy it is to reuse a flight plan. On the left, you see some dials that you can change, which will affect the altitude, the gimbal angle, and hatch angle. I want to draw your attention down to the bottom of the screen. As I change some of these parameters, this information dynamically updates to show you exactly how long the mission will take, the output resolution, the total size of the area, the number of images, and the number of batteries needed to fly your mission. Let's go plan a flight from scratch. I'll use a perimeter scan to plan out a flight. Just give your flight plan a name. And then you set your survey area. Just drag the vertices of the corners of this box to outline the object of interest. In this case, it's a bridge. So I'm going to outline the entire bridge. Once I have established my survey area, the flight application wants me to set an offset that the drone will fly at. I can make this small, I can make this large. This is where the drone will fly around my object. Then I go in and set some parameters, such as the height of the structure, the minimum and maximum altitudes. Then I'll view this in 3D to see exactly what my flight mission will look like. The red lines represent the flight path, and the green pyramids represent where images are taken. If I change the height of the structure, it'll lessen the number of flight altitudes that this project will fly. And once I'm ready, I just set fly. Connect to my drone, I go through all my pre-flight checklists, and then fly my mission. One more example, we'll go and do a vertical scan. This one's a little bit different. I just wanted to show exactly what it looks like. Just like before, I'll give my flight plan a name. Similar to before, I'll drag the vertices to my object of interest. In this case, the south side of the bridge. Next, I'll set an offset where I want my drone to fly, some other basic parameters such as the bottom and top elevation, and then I'll bring it into 3D to see exactly what this flight plan will look like. You could also set a variable slope. For instance, if I was monitoring a dam face, I could set the drone to fly up and down the dam face at an exact distance away from it. And just like before, you connect to your drone, go through the pre-flight checklist, and then fly your mission. Lastly, you can connect to previously flown flights. So here I'm viewing the June 2018 flight of this bridge survey. And you can access all of the raw images and download them straight to your iPad. This wraps up the flight planning application demo.
So it's important to understand that the flight plan library, if you will, or the templates are increasing all the time as we get, again, input from the user community. We've increased them to include daisy chaining, so you can connect multiple different flights together. If you want to do a crosshatch pattern or a perimeter survey, then connect to a crosshatch pattern, you can do that. They've also released, in the last release, they've released a corridor flight function where you are not able to fly over moving traffic, obviously. So you fly on the left side and the right side, and then land at a predetermined position to be walked across the highway or driven across the highway or getting to the other side, so to speak. Also, on the drop-down list that Brian showed, there was a list of drones that are compatible. That too is changing. The FreeFly Auterion Astro drone was brought on because it is one of the drones that satisfies many of the growing requirements from state and local governments that the drones completely are inside the United States. There's no data or information that goes outside the United States. That should be released in the next release. Also, the Matrice 300 series is also included in that. So about once a quarter or once a half, there are additional drones that are added to the compatibility list. Compatibility is a funny word in the sense that when we say 100% compatible, we're talking about the flight planning app being able to control the flight of the drone. You can use any drone out there on the market and transfer data into SiteScan in a traditional, SDE swap kind of way. You don't necessarily have to be compatible with the flight app in order to use the rest of the SiteScan components. If you have specific questions about specific drones, feel free to follow up with me. So once we've got our content, let's do another quick look at what the difference between drone to map and SiteScan.
Drone to map starts by opening it up to the template screen. I can choose from 2D rapid, 2D full, 3D mapping, or batch processing, or I can pre-configure these templates and import my own later. I'll do a 2D full job and bring in my images stored locally on my drive. Bringing in the images, the green check marks on the left indicate everything came in correctly. It's good to verify the XYZ location data with your project area. Creating the project brings the project data into my map screen. You can change and access all the Esri base maps. I'll change it to Imagery so we can get a better idea of what we're looking at. The flight data shows the blue icons representing the image locations and the orange line representing the flight path. You can view the raw images by opening up the image viewer. You can zoom in to inspect exactly what's going on. Use the carousel at the bottom to change the image, or just select directly from the icons on the map screen. Using ground control during your drone collection will improve the results because it'll tie in your drone imagery to a known XYZ location. You You can import ground control by using the import control wizard, which will bring in targets that you established during your drone collection. You can see these represented by the green targets. Going into the options screen allows you to set various output settings, as well as coordinate system settings for your project. And once you're ready to begin processing, just hit the start button. This will begin stitching together all of your drone images to create those products. Some of the products that get generated are orthomosaics. You can see that this is a true ortho, where everything looks as if it was a top-down nadir camera collection. Bringing in the digital surface model gives you some elevation data. And we also generate something called a dynamic mosaic. A dynamic mosaic is different than a true ortho because you can see the sides of structures very well. As I pan through the screen, you can see that it dynamically updates with the raw drone imagery. This is very useful for inspection workflows where you may need to see the side of the building, but also still need that true orthomosaic for your base maps. Switching to 3D, you can visualize the 3D mesh and work with the point cloud that gets generated from your drone project. Next, I'll jump into the 2D map and do some basic analysis in drone to map. If I wanted to estimate the volume of this stockpile, I could use the analysis tools and the volume tool, draw a polygon around the stockpile, and then it'll estimate a cut fill volume for my stockpile. These measurements all get saved in the measurement results on the right. You can measure distances as well as areas and perimeters. Sharing the data that gets generated with Drone to Map is easy under the Share tab. I could easily share a tile layer, an image layer, or my entire web map to my ArcGIS Online or Enterprise account. Additionally, I could take my drone project and open it up in ArcGIS Pro to access the wide range of geoprocessing tools and image analytical capabilities of ArcGIS Pro. This wraps up the Drone to Map demo.
So that's a quick high-level view of drone to map. Now let's compare that with the site scan for ArcGIS.
SiteScan for ArcGIS is our newest addition to our ArcGIS drone collections. It is a complete project manager, a team manager, as well as a fleet management system, all in a SaaS environment. Going into a project, I can see the various flights that have been flown already, access my flight plans. I could access previously flown missions to view the settings and parameters that I chose for that flight, or create a new flight plan in the SaaS environment. Similar to the flight planning application on iOS devices, I could grab the vertices of the survey area to create my own unique survey for my drone mission. Changing the various settings will update on the screen the flight pattern that I will be flying. The beauty of this is it's all stored in a flight management system, so I could access this flight as well as any of the other flight plans that I have associated with my project. SiteScan also can store all the relevant ground control data, any files associated with my project, and give access to all my team members that I want to give access to. To start a new flight, just hit the New Flight button, give your project or your flight a name, as well as the flight date. Then upload your images. Once the images are finished uploading, I could choose whether or not I want to begin automatically processing or I can go into the site scan project and set a few more settings. The icons on the screen represent the raw images of my drone flight. I could view those images in full screen, zoom in to see exactly what's going on. When I'm ready to begin processing, just hit the gear icon to begin the processing dialog. Once you hit process, it'll let you know how long it'll take, and then an email will be generated and sent to you when your project is done processing. Once your job is finished, you could go back in to view the results. Here's the orthomosaic as well as the elevation model. Narrowing the elevation range allows me to dynamically work with my elevation model on the screen. You can generate contours by setting the major and minor intervals. Jumping into the point cloud viewer, I'll increase the budget of points and decrease the size. Then zoom in to see exactly what my point cloud looks like. Everything's been colored with the RGB value from the camera collection. Some of the tools that are available, such as this profile tool, I could click 2 spots and then get a narrow range of this point cloud in the profile window. This gives me the ability to isolate points from my point cloud. I could download this file and be given a smaller last file to work with. Some other tools available are the Photo Inspect tool. I could use this and drop a point anywhere on the screen, and then it brings up all of the raw images that is associated with that point. So you could zoom in here on the top pan or choose from any of the other photos that have that location. I could use this to inspect exactly what's going on in my image. I could pin this photo, save it as a file for later, and then generate an inspection report to give to field crews. I could measure the height of the bridge. It's nice that it locks in the verticals, so doesn't matter how far off I am, it gives me the exact height. As well as measure the distance of any vector. All of these measurements are stored for later use. Going back to the 2D environment, we'll see how to get data out of SiteScan. First, I can connect to an Autodesk BIM 360 account and export all my data to BIM 360. I could share a link and share it with others, or just directly download to my PC. I could also connect to my ArcGIS Online account and publish all of the data generated with SiteScan to ArcGIS Online. I can save this in a folder, share it with the groups, give it tags to manage my data properly, and write a description so I know what exactly that data set will be. Once I'm ready to publish, just hit publish, and then you can check the status of how your publishing is going. Jumping into ArcGIS Online to see the end results, here are all my items and feature classes generated with SiteScan. I'll open up the point cloud in a scene viewer. Here's the same point cloud we were just viewing in SiteScan. This is an ArcGIS Online scene view. In ArcGIS Online, I'm able to change it to class, view the classification that was generated with SiteScan, or the elevation profile of the point cloud. I'll switch back to RGB so we know what we're looking at. And then I'll create a simple web application to view this point cloud. I'll set up this web application so that I can do some basic measurements and then launch this in a website. I could share this URL with anybody that wants access to this data. This wraps up the SiteScan for ArcGIS demo.
So to summarize a bit, the site scan for ArcGIS system or platform, if you will, is organized around you have your own organization, then you have your projects, and then you have missions that are organized and placed in each project, so that each mission can have its own coordinate reference systems, ground control points, etc.
Tom,
Some
I'm
of
sorry to interrupt. We're about
Sure.
5 minutes. We're about 5 minutes out. Just want to give you a heads up.
Sure, thanks. Great. We're just about there. Here for future reference are some of the benefits that work with SiteScan, and here are some questions that I frequently get from organizations that are trying to deploy this in their organization. It is important to maintain the thought that that you're going to need to manage the content. In managing it is a key to building an enterprise that effectively and efficiently uses it. So with that, sorry I ran just a bit long. I'm happy to try to deal with any questions that come up.
No apologies needed. We really appreciate this. I'm really a font of knowledge you bringing to us today. Let me jump in right away. It's kind of an open-ended question. Maybe you could give some light more than you already have. What
Sure.
GIS software and hardware is needed to get started?
From a software standpoint, as I said in the very beginning, ArcGIS is scalable from a simple pro installation to all the way up through enterprise image servers and the kinds of things that are needed to do stuff in a large organization. So the software requirement is pretty much a function of the deployment environment. So if you're talking about deploying in a small element or organization, you're talking about probably ArcGIS Pro. If you're talking about hardware and you want to go out in the field and you want to use, say, something like drone to map, to put it in my son's vernacular, you're going to want the best gaming computer that you can find. You're going to want probably 2 GPUs because a lot of it is done there. If you're using SiteScan, it's all in the cloud. All you need is a web browser.
Great. Another question came up, which may have been a sidebar conversation. Greg Grabner says if he was using an EB, then he probably used Pix4D. I think he was responding to somebody else. Matt Robinson, also from Esri, has chimed in and offered some requirements and some info on SiteScan. So I appreciate Matt chiming in on that. Greg also asked, is SenseFly included in the supported drones?
It is not at this time.
Okay.
I would have to check with Dev to see the 100% compatibility issue is really a function of whether or not the hardware manufacturer will give us access to their oftentimes considered proprietary control codes. And in some instances, hardware manufacturers are more open about that and quicker to respond. In others, it takes a bit longer. And I believe SenseFly is in the latter category, I believe.
Okay. Well, that's it for the questions. I'm just really impressed with the development that Esri's put into this so far. I'm excited that you've mentioned the templates and some of the upcoming hardware that's going to be available. Always thinking, what's the next step? I'm sure the battery life will become longer duration, and I
Sure.
really think this is going to be a great product.
Yeah, and in the flight planning process now, multiple batteries are starting to be incorporated. So if you're in a situation where you have a flight plan that's going to require more than one battery, it's now dealt with or accounted for in that process. And the drone is actually going to come home at about 30% to get a new battery, then go back and start where it stopped.
Smart, very smart.
And then I would also add that Matt Robinson, I work with all the time, and his region includes Indiana. So I would encourage anybody with any questions to either reach out to me directly or reach out to Matt.
Very good. So for everybody in the audience, on the screen right now is Tom's contact information. I thank you again. Matt Robinson has posted his email in the chat box as well. This presentation, along with the rest of them from GIS Day, will be recorded and available in the future. So on behalf of the Indiana geospatial community, thank you, Tom. Thank you, Matt, for your presentation today. We look forward to many more great inputs from Esri on this.
Yeah, and thank you for having us.
Thank you. Thanks, everybody, for joining us, and we'll talk to you later.